Okay, very last task for section 14.1, task 5. So here we have an application type problem. We have Micah. He read that a high school student was able to fold a long piece of tissue paper in half 12 times. So Micah folds a piece of notebook paper in half as many times as possible. The table shows Micah's results, where f of n, so this is the number of layers of paper after one fold. So when he folds the paper in half one time, that means the stack is 2 papers high. When he folds it in half again, that stack is 4 papers high, so forth and so on. Okay. We want to write a recursive rule for the sequence. We want to graph it, write a recursive rule, and then how many layers would there be after 12 folds? So first we want to graph his results. So again, let's look at my domain. Here's my domain, is the numbers 1 through 6. My range is the numbers from 2 to 64. So I only really need quadrant 1. Okay, so again, we're only graphing like 1 through 6, so I can probably spread these out a little bit. I don't know, every 4, there's 1, 2, 3, 4, 5, 6. Okay, so there are my 6 folds. And so this would be the number of folds. And my y would be the layers of paper. And so I need to get from 2 to 64. So I don't know, what do we want to count by? 2, they're all even. So maybe count by 2s or 4s, or I don't know, maybe each one, or 10, 10, 20, 30, 40, 50, 60. Or do we want every 4? Let's, because we only need to go up to 64. Yeah, let's do, all right, let's back it up. 2, 3, there. If that's 10, will that work? 20, 30, 40, 1, 2, 3, 4, 50. Oh, almost. 4, 60 will be up there. We'll make it work. This is why sometimes graph paper is a little better, whole sheet of graph paper. So for 1, we've got 2. So the middle here would be 5. So 2 would be right about here, maybe. For 2, we get 4. Well, there's halfway, slightly more than halfway. For 3, we get 8. That would be slightly less than 10. For 4, we get 16. Well, 15's halfway, so 16 would be right about there. For 5, we get 32. Ooh, we really jump up. 32, right about there. And for 6, 64. So there's 64, way up there. Okay, so we can go ahead and see that growth. So there's our graph. Write a recursive rule. So recursive rule, I need the first. The first one is 2. And then we need to look, what is that common ratio? So we need to find our common ratio. What are we multiplying each time? So to find that, we take 4 divided by the 2. It looks like that's multiplied by 2. Times 2. Yep, each time it doubles, times 2. So my common ratio is 2. So f of n would be 2 times the previous term, f of n minus 1. So there is my recursive rule. How many layers would there be after 12 folds? So we're going to have to find 7, 8, 9, 10, 11 to get to 12. Okay, so we're going to have to find all those in betweens. This is where the recursive rule is not as useful as other rules, because I have to find all the ones in between. Okay, so we take the 32 multiplied by 2 is the 64. So I'm just kind of starting partway into here. So we get 64 times 2 is 128. So that tells me for the 10th we'd have 128. For 7 times 2, 256. So that'd be 8. 512 for the 9th fold. 1024 for the 10th fold. 2048 for the 11th fold. Final fold for fold 12, 4,096 layers of paper. 4,000, so f of 12, 4,096 layers of paper. That is going to be one really thick stack of paper. One really tiny, it's going to be really small. Each time you fold it, it's half as big. One really tiny but super thick stack of paper. So there would be 4,096 layers.